And that's how you get yourself into an infinite loop. Welcome back to Understanding Python. My name is Jake, and today I'll be talking about looping. Looping is a common tool that allows us to go through our data and perform actions, wait on a process, construct more objects, and much more. Understanding and mastering looping is crucial to becoming a Python programmer. Today, we'll start off with for loops. For loops are the method I prefer for looping over iterables, especially those with a set length. Each time through the loop, it will pull a new value. For our first loop, we'll make something really basic. Just say for num in range 5. And then down here, we'll just print num. So what's going on here? Well, we're using the range method there to create an iterable that gives us the numbers 0 through 4 each time it's accessed. And the for loop will pull the number each time it goes through. So initially num will be 0, and then we're going to print it out. Then it'll go back to the top and then pull another number, 1, 2, 3, 4, etc. And once it reaches the end of this range here, it'll then exit the loop. So to demonstrate this, we'll add a print up here, give ourselves a little heading, call this loop over range. Save it and run. And here at the bottom, we see under loop over range 0, 1, 2, 3, and 4. Now if we wanted to combine a couple of concepts here, we can make a test string saying this is a test sentence. And if you remember back to my string video, we can then split the sentence apart, which would split it into individual elements based on the spaces in between. Now using for, we can then iterate through every word in that sentence. And then we can print out each word. So as the for goes along, it'll print out this is a test, and then finally sentence. We'll add the print at the top here. We'll let it run. Okay, save, run. And here we say, under loop over sentence, this is a test sentence. Perfect. Now something you'll commonly encounter is if you had a list, we'll call this test list, with some random data in here. We'll just put 5, 8, 4, 6, 9. And if you had previous programming experience in another language like C, your initial assumption would be to iterate through the index here. So we'll go for I in range, and for the range we'll use the length of test list, and then we'll print out test list and then the index I, and this is perfectly valid. However, Python lets us do things a bit smarter. So we'll get rid of this, and again we can say for num in test list print num. And much like our example above with the for num in range, this will print out each number in the list. But say that you wanted to keep track of the index of each value in the list. We can do that exact same time if we already used enumerate. So in here we'll say for index comma num in enumerate test list. What this gives us back is a tuple with a counter starting from 0 each time that it goes through, paired with the element in the list that you're enumerating. And the reason why we can iterate over two values over here is because we can do variable unpacking. If you're unfamiliar with that concept, you should see a card for that video in the top right now. So now not only do we have the number, but we also have the index, so we can print out something a little bit more helpful. We'll use an F string, and we'll say index, and that's going to map to index, and then number is going to be num. At the top here, we'll print out another header, 1, 2, 3, 4, 5, loop with enumerate. Okay, we'll save this, run it, and down at the bottom here, we see the index of 0 has number 5, 1, 8, so on, going down to 4, which is the end of it, with number 9. Moving on, now that we know that we can use the for to go through multiple items at the same time, this becomes really useful if you want to go through the keys and values in a dictionary one at a time. So create a new dictionary, testdict, and make that equal to key of A mapping to 1, B mapping to 3, and then C mapping to 5. And then to iterate over the key value pairs, we'll go for key value in testdict.items. If you remember back to the dictionary video, you'll know that items method of a dictionary will give us a tuple of the key value pair. So with that, we can print out a new F string saying key maps the key, and then value will of course print value. Make a new header up here, loop over dict items. Save it, run it, and we have a key of A with value of 1, B 3, C 5. This is an incredibly common pattern that you'll see, so get used to the way that this looks, practice it a few times, because you're almost certainly going to use it quite a lot in the future. Now you've got the basics of for loops, but there are a few more things that are nice to know moving forward. The first is that for loops also have an else condition, much like our if statements have an else condition. And this triggers when it never goes into its first iteration. So we'll create a new list, creatively named empty list. And we're going to attempt to iterate over that. So for item in empty list, print item. But since this is an empty list, it's never going to get to this point. And luckily Python provides us a way out in the form of an else. And down here we'll write out print the list is empty. Add a new header, loop over empty list, save it, run it, and down here under loop over empty list we get the list is empty because the value it's trying to iterate over is empty. So it skips all of this and goes straight to the else, printing out the list is empty. Another useful tool in for loops is the continue statement. The continue statement allows us to move to the next iteration, skipping everything else in the for loop. So for a very basic example, we'll say for num in range 10, and then we'll do a conditional check if num modulus 2 continue. And underneath the continue, we'll print an F string num is even. So what's going on here? Well, this symbol here is called modulus. So what it'll do is it will divide by the second number and give you the remainder, meaning that as it goes through the numbers in the range, if it is divisible by 2, we'll get a 0 as the remainder. And if you remember back to the video on conditionals, in the top right now, you'll know that 0 is not a truthy statement. However, when we have a remainder, meaning it's an odd number, that is a truthy statement. So for odd numbers, we'll hit this continue statement, which will skip this bottom print statement and go directly back up to the top of the loop. So let's see this in action. Loop for even numbers. Save, run it, and as it goes through, 0 is even, 2 is even, 4, etc. In general, you should try to avoid using continue statements in your loops. However, they are a useful tool to skip a section of following code and get back up to the top of the iteration. And then continuing on in the same vein, similar to continue, we have a break statement. And what the break statement does is it completely breaks you out of a loop. To show this off, we'll do something similar to what we saw above for num in range 10. This time we'll do a check of if num is equal to 5, break. Otherwise, we're going to print num. Now let's show this off. Call this loop until 5. Save it, run it. And here we see as it goes along, we get 0, 1, 2, 3, 4. Each time hitting this check, the number was not equal to 5. However, on that last iteration, it was equal to 5. So it sees the break statement and then completely exits the rest of the loop, not printing any more numbers. Okay, that wraps up for loops. Now let's move over to while loops. So while loops are a bit more basic and similar to what you'll see in other programming languages. While loops will actually continue to loop until the condition after while is false. So this is useful if you're looping over an indefinite process, or say you're waiting for something. Now while loops do require a little bit of extra setup. In our basic example, we'll set num is equal to 0. This is the initial condition. And we'll do while num is less than or equal to 4. So this is going to continue to loop until num no longer meets that condition. So once it is greater than 4, it'll exit the loop. And then we will print num. Now like for loops, it does also have an else condition, the difference being that in while loops, this will run after the condition is no longer met instead of if it is not met initially. Num is now greater than 4. And then print out num itself. We'll add a new header up here. Print loop until 5. Save it. And if I were to run this, those of you that are familiar with while loops already know what's going to happen. But I'm going to let it happen anyway. So it's running. We see a bunch of zeros. What's happening? Well, we just put ourselves into what's known as an infinite loop. And if I pull up my CPU usage, drag this down, see that my CPU usage is now skyrocketing. That's because Python's infinite loop is constantly running through this loop with no actual breaks. And that's how you get yourself into an infinite loop. To get out, we'll just Control C. Easy enough. So what's going on here? Unlike for loops, with while loops, if you're using some form of counter, you have to remember to increment that each time you go through the loop. So num plus equals 1 right here. Save that. And now loop until 5. We have 0, 1, 2, 3, 4. Num is now greater than 4 and the value is 5. So that's something to keep in mind if you're using for loop, is to make sure that you're not going to encounter an infinite loop. So always keep track of any type of counters or what your exit condition is. And say that we, again, started with num equals 0, but this time our condition is never going to be met. While num is greater than or equal to 4. We're just not thinking at this point. We'll then print num just like before, iterate it just like before, and write our else. But this time our else is going to say num was never greater than or equal to 4. That's because we're starting at 0 and we never actually meet that initial condition here, so we don't get into the loop to increment num. So we skip straight to the else. Let's demonstrate this. This time we'll add a little bit of uncertainty to our title. Loop until 5. Save it, run it, and we go straight to num was never greater than or equal to 4. Similar to for loops, we also have the continue statement. So we'll do a little setup. Word, comma position is equal to test, comma 0. Setting word equal to test and position equal to 0. And our while will be while position is less than the length of word. We'll print word at that position. And of course, increment the loop. We'll write a new else, print out, reach the end of the word. But since we want to demonstrate continue, in this case, we'll do if word position is equal to t. Then we'll continue. All right, add a new header. Loop test without t. Now some of you may be screaming at me right now because you see the problem, but I like to illustrate that. So we'll run it. And now we see, we're paused again, and I can hear my computer's fan spinning up. So you've entered another infinite loop. That's because with continue, we're now skipping these bottom statements here, which is also our increment. So each time we're going through, we're hitting the same character in the word, which is t. So with continues, you got to be careful and make sure that you're still incrementing your counter. So we do plus equal 1 and save that. Now we have loop test without t, we have es, and then reach the end of the word. Again, be careful while you're using while that you don't run into infinite loops. Now sometimes it's useful to use near infinite loops if you want to loop through data until a certain condition is met and you don't know exactly when that's going to happen. So we'll use a similar setup to what we did before, using word and position. This time we're going to say while true. So this condition will never ever be false. That means that we have to use something else to get us out of that. Continue obviously won't work because that's going to just move us back to the while statement. However, like for loops, we also have the break condition. If you remember break, it escapes the entire loop. So down here, we'll do, print word and then the position, and we'll do position plus equals 1 as our incrementer. We'll write our else. Again, reach the end of the word. But between these, we're going to do our check to see when we want to break out. And this is going to be a simple one. If position plus 1 is equal to the length of the word, then break. So this is checking to see if the next position in the loop is going to be outside of the word that we have above. Because while the length of the word may be 4 in this example, if you tried to go test and access the 4th element in it, that's going to be outside of it. And then we're going to get an error. So we'll make a new header. Again, another print. And this one will be called infinite loop with break. And then we'll run this. And we see the result is TEST. Perfect. So this shows you a very basic example of infinite loops being useful as long as you put a condition in here that eventually breaks it out. And that wraps up this video. Now that you understand looping, you can build interesting behaviors into your programs and optimize your program's flow. What is your favorite use of looping? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with the series, please consider subscribing. Thanks for watching.